Thank you to Chris and Dwayne for joining us today. Excited for your presentation. I have a whole bunch of bars popping up. One second. Thank you. Excited to have you today joining us for the ESIP November 2026 cluster meeting. We have just a couple of cluster info stuff to pass along in the video. The deadline for a January meeting is November 13th. So Cassandra will get with James and probably craft out an email to the larger cluster and ask about interest for that. They have a couple of ideas. And then we also want to announce, we'll send out this probably in another email, that we'll be looking for different clusters, cluster chairs in for EnviroSensing. As James and I have, we don't have any bandwidth left, and we think it'd be good to get a swap and some new blood into the cluster. So we'll send that email out and notification as well. And today we have, I'm excited for this presentation. I have your website up for Smart Aquaculture, right? So pretty neat. I'll drop this link in the chat for folks. But I'm going to turn it over to you, Dwayne and Chris, and you could take us out. We'll what we typically do is we give the speaker 20, 30 minutes, and then we jump into a question and answer session. And we'll just follow that format. And if you guys could introduce yourselves and take it away.
Good evening. It is 1 o'clock here in Qatar. It's always a pleasure to be involved in ESIP, in the American Geophysical Union activity. I've been involved for ESIP for over 20 years, and usually in the informatics area. We're gonna be talking about smartcomputate.org. Mr. Chris Tate is the founder of smartcomputate.org, and we got into this helping Mr. Jarvis Green of Oceans 97 and the Green Reef Foundation, and we're working to advance U.S. agriculture and fisheries outcomes. And so, Chris, I'll let you take it from here.
Okay. Yeah, I'm Chris Tate. I'm a Red Hat principal software engineer, and I also do a lot of social innovation. I've done tons of hackathons with Red Hat and other organizations, and I'm very interested in helping the environment and helping use cases with technology that need help with their digital twin simulations and monitoring and metrics. So I'm out in Salt Lake City, Utah, USA, just for some context of where I am physically. And I work with Dwayne, and we work together each day for an hour on a Zoom webinar just like this, where we build our digital twin. And so the link was shared there. And let me, it tells me host disabled participant screen sharing. So are we able to share screen?
Yes, sorry about that. Try it now.
Yeah, okay. So let me open that up. So I'll share my desktop and go to our site. So my site in general is computate.org, and over the last 20 years, I've been helping different organizations build data-driven websites with fine-grained access control to solve their problems. And some of them are just like hunting consulting companies. Others are for racial equity, social justice, and smart aquaculture is about sustainable seafood supply chain and traceability. And I work actively on a project for Red Hat called AI telemetry, where currently telemetry data like this, AI telemetry, is only available to cluster administrators. But for a shared environment like this in the mass open cloud, where we have many universities and research projects going on, we need to be able to grant fine-grained access control at the cluster level and at the project level for observability of data. So we collect observability of data over time, this way through Red Hat OpenShift cloud environment. And so the Smart Aquaculture use case is at smaq.computate.org. And we're building a digital twin to simulate fishing boats, fishing trips, fish processing plants, fishing docks, fish farms, fish populations, to put all these things on a map. So we implement fine-grained access control. So if you try to access the site and you log in, you connect with your GitHub account, because we use GitHub as the identity provider. You don't have access to any of the data unless you are granted access control. So for example, here are my user groups: admin, fish processing viewer, fish dock viewer. But if I go into our keycloak at sso.computate.org and log in with the admin account, and I tell myself, or I'm reviewing my users here. So I go into the Smart Aquaculture realm and I go to users and I look at this guy, Computate, and I say, well, what privileges does this Computate guy have? He doesn't belong to these groups, so I'll have him leave. And then on the next request, if I refresh the page, then I have no more access to the data. And this is fine-grained access control. So the fishing docks, the fish processing plants, all that data is gone. You need to be able to join a group like fishing dock editor, fishing dock viewer, and then you'll get some of those permissions back. So fishing dock viewer, I can now go to fishing dock and see that data, and fishing fish or processing viewer and population viewer, and let's see, boat. Give myself some boat viewer privileges. And then these privileges come back and we can see the boats again. We can see all these models on a map. So we import data down in Louisiana, and this is from the Plaquemine Parish GIS data source, where we can find the fishing docks and the fish processing plants. But right now we don't have a lot of live data. So what we're actively working on right now is identifying some fish populations. So let's see. So I don't have access to create any fish populations because I haven't made myself an editor of these things. So let me go and join a group. Population, editor, join, and refresh. And now I can create this fish population. So let's just call this shrimp, or we'll call it Gulf shrimp. And let's just create this. Let's see, hopefully we don't have any bugs. Okay, well, maybe, let me check. Let me join group admin, join. Let me try one more time if I can create a fish population. Okay, so maybe, I'm not going to troubleshoot this bug right now, but what we're doing is we're going to be doing some event-driven messaging to simulate a fishing boat going out from one of these docks and going to a fish population and gathering fish as it goes through the fish population and then coming back to the dock and putting those fish in the dock as data, and then being able to report over time of the fish and how old it is, how long it's been on ice, the temperature of the fish, the temperature of the water, the health of the fish population. These are the kind of things that we want, the kind of data that we want to gather to make a relevant digital twin simulation for fish population, and then be able to track the historical data of the temperature, like, let's see, I think we have temperature data somewhere in AI telemetry. Okay, well, but like we do in AI telemetry, collecting metrics over time so that we can see the health of the fish population, the value of the fish coming in, and try to help the whole smart aquaculture industry here in America to become sustainable, to become healthier, to become cleaner, to report on if the fish that's sent to a fish processing plant is dumped back into the river, dumped back into the ocean and polluting the environment. That would be a problem that we want to clean up. And then what we want to happen with fish waste is that it comes around and is returned to a processing plant where all the hard shells of the shrimp and the hard shells turns into a net zero waste solution, because the hard shells of shrimp and other shellfish is so hard and impenetrable that it can be used for body armor, and it can be used for technology and electronics and become a sustainable solution. So that's the goal of this. And the way we're doing it is trying to build a community resources where you can get started, because all of this can run in the cloud, like I show you. This mass open cloud environment is one example, where we have the mass open cloud running AI telemetry. That's a shared cloud computing environment between Harvard University, Boston University, MIT, a whole bunch of East Coast universities. And there's a lot of things going on right now in Massachusetts supporting AI and technology. And I'm in the middle of it. I'm the observability guy, and I built this AI telemetry platform to be able to observe all the stuff that's going on with GPUs and their temperature and their power utilization and their network traffic. We can observe all of that in this way. And we can also observe edge device data and IoT data in the same ways. And that's what the Smart Aquaculture platform is about. And we have the training to install it on your own computer. So if you follow these courses, like install OpenShift Local on your own computer, deploy Smart Aquaculture on OpenShift Local. You can see all the courses here. These are free courses, and you can run Red Hat OpenShift Local on your computer for free. You can run Red Hat Enterprise Linux for free, and most people don't realize that, but all of this is available for free. So by following this course, what you get on your own computer, and this works on Microsoft Windows 11 Pro, and it works on many flavors or distributions of Linux, is you run OpenShift Local. I have this running on my Windows 11 computer as well, but this is my Red Hat Enterprise Linux computer. See, so fast fetch. This is Red Hat Enterprise Linux 9.6, and this is where AI telemetry is running in development, and this is where Smart Aquaculture is running in development. So this is the Smart Aquaculture pod. And if I go to networking routes and I go to give it a sec. Here it is. There's this link to smartaquaculture.apps-crc.testing. That's the default fake domain of OpenShift Local. But I have Smart Aquaculture running here, and I can go to fish populations, authenticate through my own OpenShift Local key cloak, which is automatically deployed, and then create a fish population, both shrimp, and create. Okay, there's the same bug, but I'll fix that. So I wanted to see if it worked there too. But so then it runs in OpenShift Local. So this is like a testing environment. This is your testing environment that runs as a container. But then you can also run it locally. So if I go to Smart Aquaculture and I log into OpenShift Local in the terminal, and then I stop and start this application. Let's see, fix. Let's do this again. Okay, running. So this is my local VS Code on my computer, and it can connect to the same microservices powering the Smart Aquaculture platform, like the Zookeeper Cluster Manager for doing event bus-driven, asynchronous, scalable, message-driven requests. And we do the data import. That is all event-driven and reactive and scalable. And then I can go to this site locally, localhost :10230. And I have the same site running locally here. And here's a fish population, create test. Okay, so here I have this working in development. So I have a bug in my higher environments, but this is always under development. So I'm gonna bring these fixes and deploy them in the cloud so that we have my test fish population and the shrimp population, and bring all this all together so that we can send boats out to these fish populations and back again and do this digital twin simulation. Now this whole application is built with open source technology. It's completely open source, and you can see this site is open source. And this whole application is built with a technology that I've built over the last 20 years for building data-driven sites. And I call it spine programming, because the way this works is when I'm building a model for something, like, let me just close this stuff, fish population.java. So this is Java code. And if I go here and I start deleting stuff, like this is the API, and it's 3,700 lines of code, and there's APIs for searching, getting, patching, posting, deleting, importing, a search page, an edit page, delete, and some general methods. I can go and delete all this. And I can delete all this code. I can delete the rest of it here, which is in model, eyewear, fish population, and it's showing that there's some errors here. So if I stop and start this application again, then it's going to tell me, oh, you have all these errors because you broke your code. In fact, this class doesn't exist anymore. But what spine programming is describing what you want through code comments. And first of all, so we specify a model that has some language context of fish population. And we specify a font awesome icon. We specify that we want to return 100 rows by default. And we define some SVG that is how this fish population appears on the map, and what radius it is and on the map, and that we want a search page, an edit page, an API with this URI, and we want to search, get, patch, post, delete, and import API, and we want these authorizations. So an auth group for fish population viewer that can get all fish populations, or a fish population editor that can get, post, and patch fish populations. Admins who can post, patch, get, put, delete, and do some admin things. And a super admin is for like advanced cleanup of stuff that you mess up. Post, patch, get, put, delete, super admin, and admin. So there's a code generation service behind the scenes. This is not vibe coding with like a chat bot online that you have to pay for an API token to use. This is local sovereign AI, where if I save this file, then my watcher service knows. It says, look, this class fish population was touched, and it just created a new class called fish population page. So it's reading my code right now, it's indexing it in a search engine, and it's writing the code. And so what happened was this watcher service read this whole Java file, and it read all of these spine methods, and they all start with underscores. So it's kind of like a spine disk, and then this is the vertebrae called address, and it's got some context here for how it's persisted and what the display name of an address is and where it appears in the user interface. We define all these things as like a spine, and this is one vertebrae, and this is another to handle the alternate name, the body mass, the cultured in, the data provider, the date created, the date modified, fish removed, initial number, owner, ref species, related source, see also, all these fields that relate to fish populations, and then it generated the class for us under the hood. So it generated this class, it documented the class and explained what this class is made of. It created all the helpful public static final variables for the class that we're going to need, and it created all the getters and setters and fields and serialization and properties and things, how this appears as JSON, and it created some initialization code that's asynchronous, and it's able to initialize this whole class in the order of how it was declared. This is the spine initialization method where it takes all those fields and initializes them. And the crazy thing is we have a complete index of our code that's found in Apache Solr. And this is a big search engine record that knows everything about our class. It knows every detail, all the language context and all the code context and what this class inherits and what the APIs are. And it's able to build the code from this search engine model. It's not a typical AI model. It's got all the imports. And each individual spine, part of the spine has its own little entity in Solr. And so this is an individual method of it. And using all of this data, we can turn it into a functioning website. So if we come back here and run this application again, it didn't run before because the code was all missing, but now all of the code has been rebuilt and the site is able to run again because all of this code is back. We didn't lose anything at all. So intelligent spine programming is how this is done, and we import the data, and now the site is back here locally. So I've been talking for a long time. I'm going to let Dwayne finish up with any comments he wants to add here.
So I think you can see what an amazing work Chris has done. We are, in ESIP, we always say we're here to protect the cyber infrastructure and all the earth science data. Well, Kubernetes is the protocol that does that. So Kubernetes is this is cyber infrastructure work, and Kubernetes exists in many forms. Our form is OpenShift Red Hat, and so and also you can see here that there's a lot of potential for workforce job creation in this, and a digital twin can be applied to any process, any earth science. So when we first contacted y'all, we were contacting y'all to talk about, I think we were having a great IoT discussion and sensors and things of that nature, because we do want to try to explore that. Like if we could put maybe sensors on some of these boats and get some of these data feeds going and sensors under the water and things of that nature. So those are future things we could explore. But I think you can see there is a vast potential here. And so we look forward to further discussion and potential further collaboration. And then we may have some grant activity coming up in the future that we can also partner on. So we look for, in open source, my mentor, Dr. Peter Fox and Dr. Rob Raskins, they always said, Dwayne, always keep it open source and always, and you can see here, we're always trying to keep it free as well. And our goal is to try to help farmers and fishermen with a free service. And the earth science is a valuable tool to that. So we are very thankful to Chris for all of his great and hard work, and for believing in us and proving the power that open source is for everybody and for all communities to get involved in and partake in the earth science mission. Are there any questions?
Chris and Dwayne, that was fantastic. Really appreciate you taking the time to present that. I have a couple of questions and I'll follow up, but just closing this out. Yes, we were having a discussion about kind of AI and then also standardizing data, formats of data when we connected. And maybe it's more of a statement than a question. When you started to speak about the digital twin, this is so I work with the USGS, the Geologic Survey, and impacting our session today, undoubtedly, is the shutdown for the government agencies. Prior to that, right, we were exploring this idea of digital twins and how can we use a digital twin of our network to perform forecasting. For example, we data exhaust from instrumentation. How do we organize that and mine it to forecast when that instrument might be aging and or fouling or something? So really fascinated by that approach, and the topic in general, right? It's fish in one sense, but then there's a sensor for the fish. So it's this idea of monitoring the monitors, if you will, and networking there. So I wanted to add that comment, and it really, for me, it felt like it hit home. So would love to, if things develop and we get back to work and such, reconnect on that topic.
And on that same note, we just submitted a NSF NAR grant for ecological forecasting to bring that tool into smart aquaculture, and we're waiting for the government to open up so we can figure out if we. So we can't wait for the government to open up. We're going to be very excited.
Yeah.
Yes, I appreciate you there. Yeah, get things open back up again, right?
Yeah, and I shared so we have the Smart Aquaculture platform that is for the IoT sensing of data. And then we have the AI telemetry platform, which is built with the same technology that's for monitoring the hardware, the bare metal metrics of clusters, but also we're trying to bring in monitoring for bare metal devices. We're implementing standards, and I'd love to understand what standards you already use, but we support FIWARE standards, which is a European standard for device data. They have a format called NGSI LD. That's a JSON schema format that's to make sure that everybody knows what devices you have and what fields are available for that device, and use NGSI LD to report on the status of everything and integrate with the FIWARE context broker. And we integrate with message brokers from Apache Kafka and MQTT and AMQP and RabbitMQ. So we're able to connect all of those message brokers and build an event-driven import process for your data, where we can also query databases or any various sort of data sources and pull them in, just like we did the data from Louisiana Plaquemine Parish. We have a very event-driven reactive framework for importing data in a scalable way that's clustered, event bus driven, with Apache Zookeeper as the cluster manager that can share the load between all the pods. So you scale up the number of pods in the cloud, and then it goes from 1 pod to 2 to 3 to 4 to however many you want to handle all those events coming in. So that's what we do.
That's incredible. Yeah, absolutely would look forward to reconnecting. To the point, it's a bit of the Wild West, to answer your question for standards. We Yeah, MQTT. We're starting that protocol to telemeter back and forth between the machines. But as far as data output right now, it's kind of as given. So we it's very unorganized. So we're starting to organize on that front there. So yeah, really a topic of interest.
Nice.
For monitoring in the background. Yeah, really appreciated your talk there. Okay, Cassandra, I'm sorry I jumped in ahead of you. Do you have any questions?
Um, I'm wondering how the data is. Like you said, you can see the fish and how much it weighs. Like, how do you get the observation data to your model? Is it like near real time, or like how does that work? Does that make sense?
Well, I think you mean how much the fish weighs? Well, that would be something that we will model, and we would put a system together to actually do that for that use case. So we would you know actually perfect that and demonstrate it with sensors or in some automated fashion. One of the things we have to first work on is getting the fishermen to work together. Because the fishermen are very competitive, and our first thing is, can we work together? Because they think that if if someone is taking advantage or someone is getting more, and we're trying to create an even playing field so all fishermen have one system they can believe in, and then we can add value chain to the fish, like when he talked about the net zero waste. But this has never been done before. So we're creating a new business model for fishermen to experience and to share this technology so that they will appreciate all this automation.
Right. We're simulating this so far. So we're defining the fields and the data values required to report on the fish populations, so that when we simulate a boat going through that fish population, it's going to catch a certain species of fish or maybe multiple species of fish. And then out that boat comes from the fish population. And then it's going to, based on the values that we can change up and down, it's going to catch a certain amount of fish. But we also want to bring in ocean data to understand, is that fish in a healthy environment? Because if it's close to the coast and the water's too warm, then we want to be able to warn for those kind of systems, which means integrating with ecological forecasting data. So we're trying to find these data sources that will help us in our simulations.
Fascinating. I hope you can
It,
get
it
them
really is.
to work with you.
Yeah. Good luck. That's fantastic. We'll have to have you back on just that topic alone, right? Talking with the fishermen. Amazing, and why that I can't imagine it's much different than the farmers, right? And organizing, the early days of organizing farm fields and monitoring and the such. So, yeah, fantastic topics, and topics. It's really exciting. In my head, I'm switching things around from shrimp to turbidity sensors and nitrate sensors and samplers, right? In this ecosystem of sampler of sensors and scales, right? I mean, that's a big thing because inevitably you'll retrain your models, right?
Mm-hmm.
Chris and Dwayne on ground truth outputs, right? Our
Yes,
cluster had a
yes.
session on that.
And there's
Um,
always something, the PFAs are a big deal, and we hope this is a tool that adds to science and debate, and because we need to have debate and dialogue in this. How do we bring in the PFA, forever chemicals in the seafood, and how do we address that? And so this is an exciting time. And what we comply with a lot of the policies for AI in the workforce, data sovereignty, so that we're not just trying to do AI to say we're doing AI. We're trying to apply it to real world problems and do real world problem solving.
Excellent, excellent. Okay, well, I think I'll give you guys kind of the last bit here. We'll sign off, and we really appreciate you having us. Again, we record this, and we do get good hits on those. So apologies for the low turnout today, but we have election day, and we're also ESIP is a federal entity, and it's tough times right now. So for my fellow federal employees out there and everybody else looking for something, right, that the government should be serving, we'll hold them to it, and we'll get that services back going soon. So thank you guys for coming. Really appreciate it, and I'll just turn it off to you guys and take us out.
Again, thank you so much, and we are so happy and delighted that you had us, and we look forward to more opportunities in the future.
Yeah, thank you for bringing us on. We're excited to present to you. And if you want to learn more, go to Smart Aquaculture, smaq.computate.org. That's our site, or just computate.org. You can get there from there. And check out the products, because we have the free products to run this all on your own computer for free. Everything is free, all the free training. And then if you want to go ahead and support us, you can become a developer. And that's just the next products after you are able to run it on your own computer. And you can learn how to build your own smart data-driven website on your own computer for your own ideas. Or you can fork our platform and build it for your own needs, your own sovereign AI needs. So there you go. Thanks.
Fantastic. And so quickly, you brought that up, and maybe this could be a fantastic opportunity to do a workshop in the summer meeting, where you basically you could walk us through that, some of that generation. So thank you again. I see there's lots of future here, right? And AI with a purpose, not just AI to say, yay, we're doing it. Fantastic stuff. Thank you guys. Cassandra, thank you.
All right, thank you.